Hello, friend. Welcome to the Dreamy Scientist, a quiet and peaceful place in the universe where your curiosity can relax and where science gently helps you fall asleep. Before we begin tonight's calm and dreamy journey through space, I'd love to know, where in the world are you watching from, and what time is it for you right now? You can tell me in the comments below. It always amazes me how so many of us are lying down in different parts of the earth, yet coming together in this peaceful moment. If you enjoy tonight's dreamy adventure, feel free to give this video a soft like and maybe even subscribe to the channel so you won't miss our next relaxing journey under the stars. Doing so helps more sleepy souls find this cozy little corner of the cosmos. Tonight's story is a beautiful one. We'll learn about how galaxies, those enormous cities made of stars, are born out of darkness and dust. I hope it's not too interesting and keeps you awake, but even if it does, at least you'll wake up knowing something new about the early universe, maybe even before your first sip of coffee. So now, settle in, let your shoulders relax, take a slow, deep breath, and let yourself sink into comfort. You're about to float through 13.8 billion years of cosmic history. There's no need to hurry. The stars will be right here, waiting for you. 13.8 billion years ago, the universe was very, very small. But not small like a tiny room or a little house. It was far beyond that, squeezed into a point so compact it's hard for us to even imagine. It was hotter than the center of the sun, and packed more tightly than a scientist's schedule during prize season. And then, in a moment that's still hard for humans to completely understand, everything began. It wasn't really an explosion, even though we call it the Big Bang. It was more like space itself suddenly stretching and growing in every direction, all at once. Imagine a balloon blowing up super fast, not with a puff of air, but with the full force of the cosmos. There was no empty space where things flew apart. Space itself was the stuff, and it was creating more of itself as it expanded. In just a few tiny fractions of a second, the universe was a thick, swirling soup of the tiniest building blocks of matter. Quarks bumped into gluons, photons zoomed around like hyper little kids, and gravity, always calm and patient, quietly began shaping the scene. It was a loud, wild, and super hot place. Definitely not a good time for roasting marshmallows or watching stars. But even though everything seemed chaotic and noisy, this early universe was filled with possibility. This early universe was filled with possibility. But even though everything seemed chaotic and noisy, this early universe was filled with possibility. This early universe was filled with possibility. In this resignation past, when the moments started from that wild mix, hydrogen and helium began to appear. Two of the simplest and lightest elements. They came together like pieces of Lego, snapped from the energy and chaos around them. These small, humble atoms would go on to build everything. Stars, planets, people, pet cats and lizards, and of course galaxies. Then, around 380,000 years after the Big Bang, A very short time when we think about the universe's whole story. Something amazing took place. The universe finally cooled down enough that atoms could grab onto electrons. Until that moment, light had been bouncing around everywhere, stuck like a firefly in a glass jar. But now it could finally move freely. This beautiful event is called recombination, and it gave us the cosmic microwave background, a gentle glowing afterlight of the Big Bang that still surrounds the universe today. If we could see in microwaves instead of visible light, the entire night sky would shine with the light of that ancient fire. But even with that faint glow, there were still no stars and no galaxies. Not yet. The universe at that time was like a huge, expanding cloud of gas, full of possibility but mostly dark and quiet. If you could drift through it, you wouldn't see anything exciting, just small ripples, tiny bumps in the smooth sea of matter. These little bumps didn't look like much, but they were everything. They were the early fingerprints of quantum energy, tiny differences created in the very beginning and stretched wide across space during the rapid expansion we call inflation. Some areas were just a little bit denser than others, barely noticeable really. But gravity noticed, and gravity never forgets. Slowly, over time, those denser parts pulled in more and more hydrogen and helium, like morning dew forming on a spider web. These small collections began to grow. They were the quiet beginnings, the first seeds of what would one day become galaxies. No one could have seen them, even if eyes had existed. But they were already preparing the stage for something spectacular. It might feel strange to think of the universe as quiet, but during this time, it truly was. There were no stars shining, no galaxies glowing, just soft matter slowly falling into itself. It was a calm and silent time, like a long pause before something great, a deep breath in before the universe would breathe out light. Even today, with all our powerful telescopes and smart theories, we're still trying to understand how it all happened. How did those tiny bumps grow into massive spiral galaxies? Why did some parts of the universe become bright and crowded, full of stars, while others stayed empty and dark? The answers are written across the sky, in glowing clouds, in ancient star groups, in the quiet calm of background radiation. And so, the universe kept growing. Dark matter, which we still don't fully understand, was like an invisible skeleton pulling everything into place. Hydrogen gas flowed into thin strands. Gravity whispered, and the universe listened. Soon, the first stars would be born. Light would return. But for now, everything was getting ready. The universe wasn't just stretching out anymore. It was beginning to become something. No stars had appeared yet. Galaxies still slept, and for hundreds of millions of years the universe stayed covered in what we call the cosmic dark ages. Don't worry, it wasn't a time of castles or dragons, unless you count ones made of super hot hydrogen. This was real darkness, pure and deep. The universe was full of matter, but not yet of light. After the bright beginning of the Big Bang and the soft shine of the cosmic microwave background, everything settled into stillness. Space was full of neutral hydrogen gas, like a thick, invisible fog. No stars shone through it. No galaxies twinkled in the distance. But this quiet didn't mean nothing was happening. Imagine floating through that time, an endless, expanding sea of cool hydrogen and helium. An electron might float past you like a sleepy jellyfish. Gravity pulled on the gas gently, forming clouds here and there, but everything moved slowly. So slowly it felt like time itself had paused. No clocks ticked, no days passed, no sunrises came. Just the steady gathering of mass, patiently building up in a universe that was still taking its time. Yet, even in that deep stillness, something wonderful was happening. Nothing stood still. Heaven was black, and all the stars warmed into blue. No stars were floating. No suns were shining. Even in that deep stillness, something wonderful was happening. The sun burned hot. The universe was preparing. You see, right after the Big Bang, during the sudden burst of inflation, small bumps, tiny changes in density, were stretched wide across space. These tiny differences didn't look like much, but they were important. Over millions and millions of years, gravity began to work on them. The slightly denser areas pulled in more matter. Slowly, these bumps became strands and knots, what scientists now call the cosmic web. You can imagine the universe like a huge sponge or a three-dimensional spider web woven together by long filaments of dark matter and gas. These strands are the places where galaxies would eventually form, drawn together by the steady hand of gravity. Between them were vast, empty spaces called voids. Quiet, lonely areas where few or no stars would ever shine. And at the center of this hidden structure was the quiet architect. Dark matter. Dark and destiny. Life is a battle between the protons and neutrons. Quiet, lonely areas within the quiet architect. Dark matter. Dark and destiny. The stars is the quiet architect. Dark matter. And destiny. Dark matter is strange. It doesn't glow. It doesn't reflect light. It doesn't even interact with light at all, which makes it very hard for scientists to study. It's kind of invisible and not very social. But even though we can't see it, dark matter was absolutely necessary. Its gravity pulled the hydrogen and helium into just the right places, like the hidden wooden frame behind a painting. Without dark matter, the universe might have stayed a foggy cloud forever. Electrons from the neutral hydrogen around the first stars were knocked loose, ionizing the hydrogen and making the universe clear again. It was like someone had opened the shutters of a cosmic greenhouse and let the light pour in. From our view, billions of years later, we can't see these first stars directly. They lived briefly, were too far away, and their light too faint. But we see their marks everywhere. They turned the universe from cold and dark to warm and glowing. They made the first heavy elements, the stuff that creates everything more complex than hydrogen, including you, me, and the tea you might be drinking right now. But full galaxies hadn't formed yet. Not quite. These early stars were often scattered in small clusters. Gravity held them together, but they weren't yet the grand swirling cities of stars we see in the night sky today. They were more like tiny villages, early galaxies trying to form. When these huge first stars died, in massive explosions called supernovae, they blew heavier elements into nearby gas clouds. These richer clouds cooled more easily, collapsed faster, and gave birth to stars more quickly. The next generation of stars, called Population 2, appeared. They were a bit smaller, more stable, and already a bit more like the stars we know. And so the great cycle of the cosmos began. Gravity pulls in gas. Stars are born. They shine, die, and spread their enriched material. This lets new stars form. Each generation builds on the ashes of the last, layering complexity like sediment made of stardust. But how do we know this happened if we've never seen these ancient stars? The answer lies in patterns of light, faint fingerprints left on the universe's glass. By studying old galaxies, the chemicals in ancient stars, and the soft glow of the cosmic microwave background, scientists can reconstruct the universe's early years in amazing detail. It's a bit like learning about a forest by looking at its oldest trees, its soil, and how the wind shapes it. The clues are subtle, but they're there. And recently, we've started seeing glimpses. Telescopes like James Webb are finally letting us view some of the first galaxies forming. Small, glowing clumps of stars from just a few 100 million years after the Big Bang. We are looking into the nursery where the first light appeared. Happy holidays. Happy nursery where the first light appeared. Happy nursery where the first light appeared. Happy nursery where the first light appears. Humbling. These stars lived and died long before our sun or earth existed. Their light traveled through space for billions of years, past colliding galaxies, drifting black holes, and growing Milky Way, until it softly landed on the mirror of a telescope pointed at the sky. Now, that light rests in your thoughts, in the quiet of your evening as you fall asleep. The universe, once dark and still, had lit its first lantern. The night was ending. The age of galaxies was about to begin. The universe was glowing now, not brightly, but like the first light of dawn on a cold morning. Stars had arrived. Their light cut through the fog and warmed the silence. But these stars were still scattered. They flickered across the dark, like campfires, with no roads or cities between them. But gravity had other plans. Those scattered stars weren't just floating freely, they were being drawn together by invisible threads. If you could see an ultraviolet light and had the patience of a cosmic being, you'd watch small clumps of stars moving toward one another. Gravity was pulling them into bigger, more complex shapes. The small villages were becoming towns. The towns would grow into cities. These early cities of stars were the rough drafts of what we now call galaxies, but it wasn't neat. There were no blueprints, no cosmic engineers drawing spiral arms with rulers. It was messy. Clumps of stars crashed into each other, tore each other apart, and then merged again. The early universe was a rough place. Gas clouds collided. Stars were flung out of groups. Some early galaxies grew quickly, feeding on gas and swallowing neighbors. Others stayed small, stuck in quiet corners of space like shy party guests. Back then, galaxies didn't look like the elegant spirals or round galaxies we see in telescope photos. They were chaotic, strange-looking, more like space blobs than polished structures. Still, even in the chaos, they were growing. Slowly, their shapes became more stable, sculpted by gravity and their surroundings. Much of this early design was shaped by something even bigger, the cosmic web. You can imagine it as a huge 3D lace of matter spread across the universe. They could build things like the buildings of space, spread across the universe, where filaments of dark matter crossed, dense knots formed. The hubs where galaxies began to gather, like seeds finding rich soil. Long threads of matter stretched between these hubs, pulling galaxies along unseen tracks of gravity. Between these threads were vast, quiet spaces, empty places where few galaxies ever formed. In those dense knots, early galaxies had the most to gain and the most to fear. When a lot of gas and gravity gather, things tend to get dramatic. Galaxies crashed into each other in slow module dances lasting hundreds of millions of years. These weren't violent in the usual sense. Stars are so far apart that most didn't touch, but their gravity tangled. Tidal forces twisted galaxies into odd shapes. Streams of stars were pulled like taffy. Gas clouds slammed into each other, compressed, and sparked new waves of starbirth, called starbursts. So amid all the chaos, new stars kept forming. New clusters were born. Over time, these messy blobs started to look more familiar. What shapes a galaxy in the end? We still don't know everything, but we do know a few things. Galaxies that stayed mostly alone and had just the right amount of spin could flatten into elegant spirals, like our Milky Way. Others, hit by collisions or forming in crowded places, became elliptical galaxies, round and puffy with older stars. Some never settled down at all, staying lopsided and patchy. We call them irregular galaxies, and love them for their wild appearance. Even in their strange shapes, galaxies had become something new, something lasting.